Hi all. Today we are going to see the deletion operation in singly linked list at the end. Singly linked list at the end. If a node is deleted from the end of the linked list, there can be any of the two scenarios. First one is only one node is there in the list and this node is to be deleted. And the second one is more than one node is there in the list and we need to delete the last node of the list. In the first case, the only node head of the list will be assigned to null, because the condition head next equals null will survive. We can use the below statements for this. ptr equals head. Head equals null free ptr. Case 2. We need to traverse the node to reach the last node of the list, because the head next equals null condition would fail here. We will thus declare a temporary pointer temp and assign it to the head of the list and keep track of the second last node of the list. For this purpose, we can use the this statements, where we are using two pointers ptr and ptr1 to point to the last node and the second last node of the list, respectively. ptr equals head, while ptrgt, next, equals null. ptr1 equals ptr. ptr equals ptr, gt, next. Now, we will use the below statements to make the pointer ptr1 point to the null and the last node of the list that is pointed by ptr, free. ptr1 gt, next equals null. Free ptr. Now we can see the algorithm for the deletion operation performed in the singly linked list. Step 1: if head equals null. Write underflow. Go to step 8, end of if. Step 2, set ptr equals head. Step 3, repeat. Steps 4 and 5 while ptr, gt, next exclamation mark equals null. Step 4, set preptor equals ptr. Step 5: set ptr equals ptr, gt, next, end of loop. Step 6, set preptor, gt, next equals null. Step 7, free ptr. Step 8, exit. Let's look at the Python program to delete an element at the last of the linked list. In this method, the last node of the linked list is deleted. For example, if the given list is 10 gt, 20 gt, 30 gt, 40 and the last node is deleted, the list becomes 10 gt, 20 gt, 30. Deleting the last node of the linked list involves checking the head for empty. If it is not empty, then check the head next for empty. If the head next is empty, then release the head, else traverse to the second last node of the list. Then, link the next of second last node to null and delete the last node. Now look at this program. Def pop _back self. If self.head equals none. If head in not null and next of head is null, release the head. If self.head.next equals none. Self.head equals none. Else, traverse to the second last element of the list. Temp equals self.head, while temp.next equals none. Temp equals temp.next. Change the next of the second last node to null and delete the last node. Last node equals temp.next. Temp.next equals none. Last node equals none. The output will be: the list contains 10 20 30 40. The list contains 10 20 30. I hope all of you understood the concept. So let me conclude. Thank you all.